So here's a video on lab 2 for 111 online. It's a three-part exercise looking at a marble go down a ramp. So you're looking at the motion of a marble on a ramp. In part one, you'll use your little ramp with a groove and the marble with a stopwatch to set the ramp up at three different angles and roll the ball down the same distance each time and time those intervals. The instructions of HOL show you how to make a plumb bob to calculate or to measure what the angle of the ramp is for each angle. So in part one, three different angles, same distance down the ramp. Then you'll calculate the average time, then the acceleration and the velocity of each trial. In part two, you're going to use the same angle the entire time, except you're going to roll the ball down from three different heights. Again, get the time for, I think they use five different trials. So time, five different trials. And from there, you can get the average time. You can also measure the distance that the ball rolls down using your ruler. And then from that, you can then get average time, acceleration, and velocity, just like you did for part one. In addition to that, though, you'll also create a distance versus time plot and a velocity versus time plot in Excel or whatever your favorite graphing software is. If you've never done any graphing, I recommend Excel. You can literally just enter your time in one column, your distance in another column, highlight both columns, and then create a scatter plot. From there, you can then add a trend line. Um, so I might make another video to just look at doing that because messing with Excel can really be hard. But if you have any issues with Excel, you can simply just Google Excel trend line and they should clearly show you how to do that. So for part two, you'll use Excel to get a distance versus time and a velocity versus time plot. And then for the distance versus time, you'll apply a trend line of a quadratic equation, which is of the form ax squared plus bx plus c. And then the velocity versus time, you'll apply a trend line of mx plus v. I can actually show you some of this on the computer. All right, so let's see. Go back a little bit. Data table one, like I said, they just same distance down the board, just change the angle, three different angles. And when you calculate the acceleration at the end, you can see that the larger the angle, um, the higher the acceleration. And that makes sense because the ball is going faster, accelerated faster. If you drop a ball straight down, it's going to go even faster than the ball rolling down the ramp. That's kind of like the extreme here. But as I was just talking about data table two, uh, distance will change, the angle will remain the same. Five different trials, get the average time of each, then you can get the velocity and acceleration. And then here is quadratic applied to the distance versus time plot. So you can see the trend line is this dotted line, so it fits really well. And then for velocity versus time, here's your three data points, and here's its y equals mx plus b. So this is a linear fit where m is this value right here, and this equation fits the form of v equals v naught plus at. So the acceleration of this ramp at this angle is 0.521. So you can see on data table 2, the point or 0.52. They use two decimals. So that's where this value comes from, is the trend line value from the velocity versus time plot. So that's that. And then on part 3, you use your ramp with the wooden grooved ruler as a flat ramp, as a flat surface on the end of the ramp. And then you'll release the marble from the same spot every time, calculate the velocity at the bottom, and then you'll measure the time it takes to go up different lengths of the flat surface ruler. So that effectively starts each trial going down the flat ruler with the same initial velocity. Plenty of good instructions on that part in the HOL manual. Just like part two, get average time, get acceleration, get velocity, do some Excel plots, get the trend lines, but this time the trend line acceleration should be negative because when you start with initial velocity going down a flat surface, if there's nothing to accelerate it, friction will eventually slow it down. So you have a negative acceleration because these ramps and this ball does have friction. So it eventually does, it would stop. If your ruler could go on forever and it was perfectly flat, the ball would stop. So this should do for part 3. The lab report is on part 2, which is data table 2. So quickly summarize the purpose, the purpose section. The measured values for that section would be the angle of the ramp, the distance the ball rolls, and then the times of the 5 trials. For the purpose in the intro section, don't actually list what your values or what your results were. So don't say it took 0.2 seconds on average to go down the ramp. Like, save all that for the results. Just talk about what you will measure. Calculated values would be average time, the velocity, the acceleration, and then the trend line acceleration. The principle of this lab is just 1D motion, or you can say 1D motion on a ramp or something along those lines. But those 3 things would cover the purpose. For the introduction, the formulas that you're using are acceleration equals 2 times the distance over time squared, so A equals 2x over t squared, and then V equals AT, or the velocity equals the acceleration times time. It's also plus V naught, but your initial velocity is 0 because you're releasing from this. The assumptions are you as a user making accurate measurements with the stopwatch, and that you're releasing from the distance that you are measuring or stating. That would cover the introduction. The results section just state, let's go back to data table 2 here. For the results section, take the average of these 3 accelerations and compare that number to the 0.52. So just eyeballing this, I don't know, it's like 0.66 or so would be the average. You can compare that to 0.52, and you can use a percent difference formula. So percent difference is the difference over the average. So we had 0.66 and 0.52, the difference of those and the absolute difference. So 0.66 minus 0.52 or 0.52 minus 0.66, absolute value of both of those is the same number. Just like 3 minus 2 or 2 minus 3. They're both 1 if you're looking at the absolute value of 3 minus 2 and the absolute value of 2 minus 3. So take the difference of the 2 and then divide that by the average and then multiply that by 100. For validity in the results section, you could say if that value is less than 5%, your result is valid. If not, invalid. And again, if it's invalid, don't stress about it. Just write that it's invalid. And then in the conclusion section, try to explain why it's valid or invalid or why it's not perfect. So that's a little bit of a brief discussion of lab 2, also about the lab report at the end. So if you got any questions, please send your TA or me an email and we'll be happy to help. So bye.